Thanks everyone. Thanks for attending this. Just like to acknowledge my co-authors on this paper from both Shell and AWS. We put this together. For some reason, I'm the only one that has a slide that looks like this. I don't know. I figured my Exxon friends would have it too, but this basically says don't make any investment decisions based on anything I say today. As we've seen, these kind of journeys are collaborative efforts, and so I would just like to acknowledge all the people from both Shell and AWS that have worked together on this journey to make what I'm going to talk about here possible. This is everybody. It's R&D folks, IT folks, domain specialist folks, commercial folks. I mean, it takes everybody. And so why are we here? What am I talking about? So, the premise is, is hybrid cloud the way to actually unlock seismic compute in the cloud? And I think we've heard various presentations today, and people will talk about the cloud and say, well, maybe someday, not for seismic, for other workloads. What are we after here? Business is wanting their data faster. They want higher quality. Things are becoming more geologically complex, which means we need to put more intensive algorithms, put more physics into our algorithms. And this is driving us toward these wave equation kind of algorithms that we've heard about, the full waveform inversion, RTMs. And these algorithms require significantly more compute. They scale as kind of the power of the 4 to the frequency, and your compute needs go up rapidly. As we start rolling these out, what we see is our workloads are becoming increasingly wave equation based. If I look across all the compute cycles our data center spends, we're up in the 60, 70% are wave equation based, and as we get more physics in, that's going to grow even more. And these algorithms are particularly well suited to GPU in terms of what we've heard with power, in terms of turnaround speed. So what we see, and I have an example, a little one on the bottom right, where last year we ran just one project with a simple kind of on-grid full waveform inversion. We put a couple hundred GPUs against this for 2 weeks, got the answer out. But if I start putting more complicated algorithms in, start adding tilts to that, then say it goes up by a factor of 4, so my 2 weeks, 15 days goes to 60 days. And then if I really put in all the physics that we want, go full elastic with tilts, like we've heard talked about, it's another factor of 5, so 60 goes to 300 days on 200 GPUs for one project. That's a bit longer than the business is wanting to wait. So what do we do? I looked, and Shell have increased their HPC capacity by about a factor of 20 over the last 10, 12 years. We've been able to do that fairly flat cost because of the advances in the hardware. But every time we do that, utilization goes way back up. We start using all of that compute again and again. And so, right now we're well over 90% utilization. We don't have enough compute. We're having to prioritize project, which ones get to go, which ones don't. See some of my colleagues nodding their heads. Also slows us down on the innovation side. The R&D folks would say, hey, we'd like to run some tests. I'm like, no, I've got this high priority production project, so you can't do it yet. So this is kind of the challenge that we're facing today. So then what are the options? Want more compute? Everybody said we need more compute. This whole conference is about getting more compute. So what do we do? Traditionally, we've just looked and said, well, let's buy more nodes and put it on premise. You can do that till you run out of power, and then you got to put it in another data center somewhere. But that's what we've been doing, right? Just buy more nodes, you put it on premise, you got full control. It's the way we're working, no big change management. But I incur a fixed cost, and I pay that cost, and I have to make sort of multi-year commitments up front. I still never have enough for the peak because, to justify the expense, it's more of a bill for the average. Procurement right now is no picnic, right? If we decide now, hey, let's double the capacity, it's at least 6, 9, maybe even 12 months. And you may be a little more limited on the software side as well. So what are the other options? Well, I've heard this thing called the cloud, and they talk about things like elastic compute and infinite compute and all this. So would that be an option? And so let's just pretend that it is, right? That I have a problem. I want to go on this particular date, on this particular project, I want to go really fast. And I'm willing to pay for it. So you become much more of a project-based VOI, value of information. For this project, I'm willing to pay. I want to go fast. Scale up when I need it. Let it go when I don't need it. Hopefully, access to resources are faster in the cloud. Maybe there are options that we all work together in this cloud environment. We start sharing infrastructure. You can start sharing maybe workflows, work practices, some of the more common stuff we could share amongst each other. But yeah, the weakness is maybe it costs more than if I build an optimized system on-prem. If I go ask my friends in the cloud, how many GPUs are available for me tomorrow? They don't really have an answer for that. So it's a little bit unpredictable right now. And we've certainly seen that if I look full end-to-end workflows, cost does become an issue, and it's not particularly commercially attractive. But maybe on the GPU side, maybe if I know I've got a project coming in 2 weeks or a month, and we say, hey, in a month from now, could I get a certain number of GPU available? Maybe that's an option. The other thing, well, does the cloud have what we need? We've heard about how difficult it is to design these systems to work for Seismic. Seismic's a little bit special, a little bit different. But when I saw AWS publish this last May, June, I said, well, this starts to look kind of interesting. I mean, at an architectural level, it looks a lot like what we would build on premise. Kind of a CPU node with 8 GPU nodes, kind of GPUs that we're using. Significant number, 4,000 of them, right? So I mean, if I had access to that, my 300-day problem could come back down to maybe a 30-day problem, if I can figure out how to scale that well, but that's a different issue. So we started looking at this, and the thing is, the commercials, GPU commercials in the cloud are actually quite similar to on-premise. So we actually saw that in the GPU space, commercials are comparable. I think there's also the opportunity in the cloud space that maybe I can refresh, right? If I put something in on-prem, I've committed to it for 3 years, something new comes along, what do? I either increase my on-prem cost or I wait. And then there was one final piece, and that's the direct connect, high-speed direct connect that I found out about. And so what do we have? What do we have now on the shell side? So when we look at these workflows, what I find is the original seismic data comes in, it's pretty big, 100 terabytes, say, of data. We do a lot of, CPU-based workloads in the beginning, and we get that down to, say, something like 10 terabytes going into our velocity model building process or our imaging process. 10 terabytes, is that doable to transfer up the cloud? Well, last year, sort of again, about May, June, somebody said, well, you can get 10 gigabit per second connections now. I said, oh, really? Started doing some math. I said, well, that may be something that's interesting. So we started with our wonderful shell procurement process, and a couple months in, it wasn't going too fast, so we threw a second horse in the race, and somehow ended up with 2 10 gigabit connections within a day of each other. So anyway, so now we have 2. And that, it's directly from our data center here in Houston into the AWS data center. We can really transfer terabytes of data in a few hours. And one of my colleagues sitting in this room, not to be named, transferred 30 terabytes overnight a couple of weeks ago. So that starts to get interesting. And so what it has for us now is we're actually in production with some dedicated capacity in AWS. We connect to via the Direct Connect. And we're working on making sure that when we want to burst, that we can burst into additional capacity for faster turnaround. We see the future of these kind of algorithms all on GPU. We see this as a viable model going forward. So I told you the answer, but it's maybe a little bit instructive to look at how we got there. So we've been working with AWS in the subsurface space since about 2017. But in the beginning, we started, like, we don't want to change anything. We don't want to change our code. We don't want to rewrite stuff. Let's just lift and shift. It's cloud, infinite compute. They got a lot of computers. They got a lot of smart people. Let them figure out how to make all this work. So we did that. We put a couple of people on it. We'd do a project for 2 or 3 months. And we were very much hung up on the commercial side. I run this workload on-prem. Let me run the exact same workload at the same scale in the cloud. How much does it cost? So we got real hung up on that. Cloud storage is very expensive for what we do in Seismic. We're all, focused on CPU. And, the upshot is we learned a lot. We weren't successful, but we learned a lot. So we did figure out we got to change our software some if we're going to make this work. We probably got to think a little bit differently about how we're using the cloud because, the traditional way of using the cloud, things weren't working. We showed we could do it. We could lift it up there. We could run it. It just wasn't particularly effective. The one thing that I do take away from those early days, we'd go do a POC. We'd find something that wasn't working well or could work better. We'd find, some capability that wasn't there that could be better. We'd write up a little after-action review of report. And we'd come back a few months later, and our colleagues at Amazon had actually taken all that, and they had made those changes. And so I thought that was really good. They do pay attention to what you're doing, and they do try to make it better. Those early years, I wasn't involved, but in 2020, I came into my current role. And like I said, we've been going at this. It wasn't particularly going very fast. So I said, what can we do? What can we do differently? And so I told the team, I said, don't worry about how much it costs. Let's try to do something in the cloud we could never do on-premise. Let's try to go 10 times faster with our workflows than we ever could on-premise. Doesn't have to be each step, but overall, 10 times faster. We recognized we needed to modify some of the code, some of our job submissions, so we started doing that. We moved to Lustre for storage. We're still using CPUs, because that's where we were with our code. And like I said, just take away the commercial focus. That also didn't work. We just couldn't get the CPU workloads to scale as big as we wanted to. But like I said, middle of last year, the stars started to align, whereas internally we started really getting the production level FWI workloads on GPU that were running for us at scale on-premise. Amazon announced their big GPU clusters, high-speed network. And so we really refocused the team. In over 7 months last year, we pivoted, and like I said, we got to production. We're in production by the end of last year. And so that's where we are right now. Starting into this year, what are we trying to do? Burst. So we've demonstrated we can burst, just take my current capacity and go give me that much again. We did that. But I'd like to go much bigger, right? I'd like to get to 10x. We're going to get more physics. We're going to need more capacity than we have right now. Every time you start to scale, you break something. And so you have to figure out, okay, what's broken? How do we fix it? So you can't just give me 10 times the number of GPUs today and it's going to work. So you're going to have to engineer these workflows. But right now, just leaving storage and CPU on-premise. It's portable, it works, and then I can burst up into the cloud when I need it. And we are working with our friends in AWS that, what could these systems look like that would be a little bit more attuned to what our workloads look like. And again, like you say, they do listen. So with that, this is where we are. Next step is really try to get that large-scale elasticity, thousands of GPUs at attractive pricing. So to do that, need some help. We need to make sure our workflows work, but we also need favorable commercial terms. We need availability. I mean, even the cloud's not infinite in being able to get the hardware. We're also looking at, like I said, if we can all get into this sort of shared infrastructure, what other possibilities for sharing are there? We see those as a nice to have. It's not the main driver here, but if we're all there, then that could be a nice to have. We do see that getting more scale, right? So if the AI people are using this kind of hardware, if we're using this kind of hardware, I think we heard this morning, it's the AI people are going to drive it, and so we better learn to use their hardware. So let's do that, and so we are working together, trying to build up this demand. We do see this as sort of the first step in the journey. If we can get there, it helps us move away from this kind of fixed cost and into a more variable cost that are driven by project demands, and that's where we are.
Okay, do we have any questions for Tim?
Thank you. Hey, Tim, great presentation. Thank you. Just a quick question. My understanding is this is a hybrid. You burst into the cloud, so there's no cluster running in the AWS at this point. It's just on need basis, it bursts into the cloud if you need more resources. Is that true?
So what we did is we've given ourselves some dedicated resource in AWS that we always have. We found that's been very beneficial in terms of us learning how to use that and to use that, how things work in the cloud to engineer our workflows to help us scale. So we do have a certain amount fixed, but it's not everything that I want to use. So I kind of have that base load that we always have, and then I want to be able to burst on top of that.
Secondary quick question. You mentioned something about bringing 30 terabytes of data overnight. How does that impact your cost strategy moving forward? I mean, that's one of the concerns.
So you're talking about the high-speed data
Yes.
transfer? Compared to the overall cost of the data center, the network costs, they're not, they're in the noise.
Yeah. So I have a quick question. So did you guys just use the computation from AWS, or you guys also use the storage from AWS?
I mean, the main thing we're doing here is using GPU computation. Of course, you have to have storage alongside of it, but that's temporary for the project. So you upload it, you run the project, you download the results.
Okay.
And then
So if you use the storage of AWS, how did you guys handling with the data security? Like, is there data encrypt or some kind of things?
yeah, so I mean, like, I was the only one that showed this big giant disclaimer at the front. Shell have a whole army of people making sure that everything we do in the IT space is secure. You can make AWS as secure, if not more secure, than your on-premise stuff. So I don't know the details, but it is handled.
Thank you.
I wouldn't be allowed to do it without it.
Yeah, there is an army, believe us.
So how do we compare the financials, the total cost of ownership of bursting out to AWS for storage and capacity or computing versus having the investment on-prem, like in percentage on a very high level?
Right.
And how does the egress cost factor in this?
So, so again, I think it depends a lot on what workload you're talking about. For GPU-based workloads, the commercials in the cloud are very comparable to on-premise. per CPU and bulk storage, 100 terabytes and petabytes, they're not. Cloud's more expensive. And so that's why I'm saying the hybrid approach is actually what's working for us right now. I can leave the part on premise that we're cost effective at in terms of storage and CPU workload, and then I jump up to the cloud to do the GPU workloads, and then bring the results back down. 10 terabytes up, 1 terabyte comes back down kind of thing. So the egress are not, AWS, I think they let you load up the data, they don't charge you, but when you take it out, but it's not material.
That's why I love the hybrid approach.
Right. Right. We got another one up here, and then
Hey, Tim, question on this data transfer. I get the technical side of direct connect and the speed of that. Do you do that as a manual process, or do you have that automated as part of the workflow? And have you done it often enough to know how much your users like that or dislike, or what the issues are on the user side with that?
so, I mean, we started with manual kind of AWS CLI, transfer some stuff up. We're automating more and more of that, and we're integrating it into sort of our job submission system. So it's becoming more and more automated. You want to try to hide that as much as possible. So Seismic processes, submits the job, and then all the stuff happens.
Is this on? Hey, I know this is a technical conference, not a commercial conference, so I want to ask you a bunch of questions about how you're getting cheap GPU in AWS, but I'm happy for all my AWS friends that come talk to us later. Yeah, that was, I know. So no, my real question actually is around the types of compute you're using the GPU nodes for. So ExxonMobil, Steve just did a talk about our big GPU system, and one of the things that separates the big GPU systems from just a bunch of GPUs is the big network and the types of ways that we stitch those machines together.
Yep.
We're solving problems that are really rely on that interconnect working really well. Are you guys using just single GPU instance compute, or are you actually spreading that compute across multiple GPUs in multiple chassis? And if so, how's that working?
So, I mean, like I said, the architecture that they showed with their P4D cluster, that's what we're using. We're using multiple GPUs, multiple nodes of GPU. I don't know exactly how it's all configured in the back end, but what we have is able to work for our workloads in a reasonable way. We're continuously trying to optimize them. We're continuously trying to figure out how can we make it more efficient. If I take right now, and when I doubled it, I'll be honest, we didn't get 2x the scale, because when we scaled some other things like you guys found, you start to find other bottlenecks. So we've got to start working through some of those. All I said is that commercials are comparable to what I have on-prem. Maybe you're more efficient on-prem than us, but yeah, that's right. So I knew it was right before the break, so I didn't want to take too long.
So I have a quick question. You mentioned partnership a couple times on the slide. Can you expand upon that and how it's being enabled?
So I think partnership is sort of what we're doing with AWS, I consider a partnership, right? We're working on this together. Expanding past that, I'm here. I'm hoping people will get interested in this and come talk to me about it. So in that sense, it's an aspiration right now. It's not like I have 15 people lined up and we're all going to go do this together. But I thought it would be good to bring it to this audience and see if there was interest. It wasn't particularly, so people say it wasn't particularly a strategy when we got started on this in that sense. But what I have been told by some of the folks working in this space is that they find this pretty exciting versus what they had been doing. And so there's actually, an employee value proposition here. People find this kind of stuff interesting, exciting. If we stopped using oil and gas tomorrow and they needed to go find another job, maybe they would have something that So if you can figure out how to do the second thing, please let me know. So I mean, there's no magic here. There's no magic here. You know, we are able to, you know, have the conversations. What's the new hardware look like? When's it coming out? You know, and instead of us installing it on premise, then we just start to get access to it. You know, you could get access to it in a burst way. You could start to get access to it by pre-committing or some combination thereof. We just see that overall we can give ourselves a little more flexibility than what we've traditionally been doing on premise.
So, yeah, so we're starting to see, you talk about partnerships, we're starting to see the same type of requirement in the AI, in our AI training space.
Okay?
Because they have to train a large model. Once they're done training, they're done for a while. Then they go off and inference, and then sometimes come back train. How predictable can you see your demand? I mean, theirs are pretty predictable. When they need it, they know 2 months out that they're going to need access to a large cluster, and for approximately how long?
Right.
Because they're looking at the hyperparameters, how many tokens they're
Yep.
dealing with. So they're pretty predictable.
I think we can be as predictable, and I think there are some synergies exactly in that space that we're trying to unlock a little bit. I think there's a lot of GPU. I think there's a lot of GPU sitting around that's not being used at certain times that we could use. Yeah, ChatGPT may fix it. But that's on somebody else's cloud right now, so that's